In this segment, we're going to talk about some of the overall structure of the code and get into some of the details of file reading and estimating the language model. So you're basically given 4 files here. You have main.java, Bigram language model.java, and then 2 data files. So the first wiki.train.tokens is what we call our training set. That's what we're going to count up to estimate our language model probabilities. And then we also have our test set, which is a set of unseen data, which we're going to use to see how well the model effectively kind of captures the probabilities and how effective it is on data that we've never seen before. So the basic steps that we've discussed are we need to read in the data files. We need to learn the model by counting up all of the words and word pairs that we see there. And then we're going to test the model. We're going to draw samples from it, and we're going to play around with it. So I'm mostly going to talk about these first 2 steps here. So you can look at the code and follow along here, but we're going to go through it mostly at a high level because you're not going to be modifying this stuff too much. So for the file reading, in main, there is a read wiki text method, which returns a list of lines, and each line is a list of strings. And each line is basically from the file, so if you open those data files and look at what's in them, you'll see things that are like this. Green background indicates when, parenthesis, 2 points, close parenthesis, and that gets turned into a list of strings. So that list of strings basically has the stuff from the file here, but you'll notice that we've also added this start token, bracket s, at the beginning, and this end token, \s, at the end. These are placeholder tokens. When you have a bigram model, you're going to calculate the probability of the first word conditioned on this start token. And then we have an end token that you're not really going to need to use much, but it's there just to kind of have something to tell you to stop generating a sequence. But it's not going to be too important for what you're doing. All right, and so then the main way that this file gets processed is in Bigram language model.estimate, which is going to count up words by looping through the training file and computing all of the things that we need. Okay, so this is what, so we're going to walk through that formula that we saw earlier and see how this counting process actually allows us to compute these probabilities. So we had this sort of crazy looking formula here, which had this term with the word pairs at the beginning, and then this term that we said was basically this unigram language model probability, just the probability or the count of a single word divided by the total number of words. So we need to compute several sets of counts in order to actually be able to compute this. So the first we have this data structure called bigram counts, which is the most complicated one here. This is a map from strings, and each string gets mapped to a map from strings to integers. All right, so this kind of 2-layer map lets us do the following. So we can call get on the previous word and then get on the current word, and that gives us a count for how many times, in this case, we saw dog after the, or how many times we saw the pair the dog. It's just a way of basically keeping track of counts of word pairs. All right, so then we have the context counts, which are just how many times we saw the before some other word. And then we have our unigram counts here on the top right, which is again, another map from just string to integer. And this is just how many times we saw the word the. This is very similar to the context counts, and actually these things are going to be the same most of the time. They only differ really in thinking about the start of sequence token and the end of sequence token. And I'm not going to go into too much detail about that because they, more or less you just want to take what's there and plug it into the formula here. So these counts are basically the way that we compute these probabilities. When we're given words, we can look up the counts of those words and then use those word counts to, in this formula with the lambda values to compute these probabilities. Okay, so in that process, which is defined in getProbability in the Bigram language model class, we need to think about one slightly tricky case, which is what if count of wprev equals 0? Then it turns out we end up with this 0 over 0 thing, and that's not what we want. So typically what we need to do is make sure that wprev actually has some non-zero count, and then wprev is actually in the first bigram counts map as a key. And I'm going to write a little piece of pseudocode here. So it looks a little bit like the code that's there, but it's a little bit simplified. And basically, if wprev is not in that map, then we only return the second term. We don't worry about the first term at all. Otherwise, we count up both, or we take the counts of both wprev and w as a pair, and then we return basically this whole formula from above. So that kind of introduces how we go from the raw data files to the probabilities here. And next, we're going to talk about what we can actually do with this code, and we're going to get hands-on with it. That's the end of this segment.